the
Yeah.
two, and then we'll do the questions. So
Yes.
whenever you're ready.
I want to make sure that I can forward the slide. We'll be able to forward the slides here. Just 1 second. Just 1 second here. Oh yeah, it's here. Okay. Thank you very much for such a warm welcome. Good afternoon or good morning. For me, it's an early morning here. Very nice to participate even virtually. So I'm a PhD student from the University of Toronto, from the Ontario Institute for Studies and Education. That is the name of my scientific advisor here on the slide, who unfortunately wasn't able to participate today. I'm also an Ontario certified science teacher. I teach chemistry, biology, and general sciences. And my background research is in biology and related disciplines and areas. So I will be talking about a learning community model and how students explore the nature of science and their STEM identities in high school biology class. Okay. A little bit about the structure of a high school science education in Ontario. So we have 12 grades. High school, it's from grade 9 to grade 12. In grades 9 and 10, students have only one science subject, which is a mandatory subject. And this subject includes units in biology, chemistry, physics, and earth and space science. And in grade 11 and 12, students can choose. So these are separate subjects. They're not mandatory anymore. Students can select biology, chemistry, physics, or environmental science, or all of these sciences if they want. Okay, so I would like to describe here in the next 10-15 minutes the curriculum that I'm developing with the biology teacher at the high school in Toronto. It's a grade 11 biology curriculum. It consists of 5 units, which are genetics, evolution, biodiversity, plants and animal systems. And to this curriculum, we added a cross-cutting diet and nutrition theme to keep students more motivated and interested in the topic, and just to unite all topics. And these activities involved case studies, scientific data analysis by the students, student discussions about credibility of primary and secondary resources. And the activities are aimed at the exploration of the nature of science, through students' evaluation of scientific findings and creation and evaluation of arguments. And also in each unit throughout the school year, we included exploration activities aimed at the exploration of students' STEM identities. Okay. A little bit of background here. Students from kindergarten till grade 12 generally receive insufficient opportunities to engage in projects which include data collection, analysis, and collaboration, especially in science classes. They quite often struggle when they need to evaluate the arguments, conclusions of other students in science classes, and they often have difficulty in developing hypotheses, choosing the right evidence, and justifying why alternative explanations should be excluded. And so my main focus is on how students explore the nature of science and helping them learn about the nature of science, which is an understanding of how scientists work as individuals and the community, how knowledge is generated and validated, how science interacts with technology, society, and environment. From the literature, we know that the understandings of the nature of science can be achieved through student-centered discussions and social discourse between the students. And a learning community approach can support students' engagement and inquiry activities by adding authenticity and participation in the practices of science. A little bit more about the curriculum that we are developing. Of course, we're addressing curriculum expectations, but as I said, we included a diet and nutrition theme that goes through all units and results in the final project for students. just some examples here. For example, for animal systems, we talk here about digestive systems. So we talk about what our food consists of. We look at the real case studies, such as different types of diets. Then we'll look at different issues such as diabetes and different conditions. Or for genetics, we'll look at the obesity gene in selected populations, and some other topics that are listed here. For example, for evolution and biodiversity, we're exploring the diversity of humans' gut microbiota and its co-evolution with humans' digestive system. Then, as I said previously, in each unit, we add career connection, where students contribute to a career folder and career documents. I will show this later. And the culminating project for students is where we connect all units, such as students participate in debates, or they can write a short paper about the ideal diet for themselves, for family, or for the community, or some more local issues, such as, for example, strategies for supporting the health of indigenous populations in Ontario in the context of diabetes and healthy lifestyle. Okay, here we're applying the KCI model, which is a knowledge, community, and inquiry model. And in this model, students work collectively. They co-create a knowledge base, and it is built progressively using available technologies and platforms such as Google Drive, Google Documents, and, for example, Padlet. And the knowledge base, so the documents that the students start creating from the very first day of their classes, these documents are used by students in the next units progressively. So students can add to these documents or edit them. So by the end of the course, we have the many folders, and students can also see the progression of their ideas and of their learning. Students work as a whole class in groups and individually, but the major focus is on the group work. And our main goal is that our students participate in the practices characteristic of the real scientific community. Some examples here, I will not go in all these small details here. For example, as I said, for example, students are progressively building the common knowledge base, such as about primary and secondary resources. So here, this is example of a sort of scientific argumentation. We did not go in too much in details here, but we try to model scientific argumentation in the classroom, where the students have claim, evidence, and reasoning about different resources. So they look at the primary and secondary resources. They can find them, or the teacher can suggest them. And they look at if the resource is reliable, if it's outdated, who wrote this paper, and they try to rank them according to the according to the chart that we provide. And here it's more explicit learning about the nature of science, where students again work in groups, trying to sort the statements related to scientific theory, hypothesis, scientific law, scientific principle of fact. And at the end of this activity, we join together as a class and discuss these tables that we create of the findings by the students. Also, we're trying to look in the real papers. So these are real papers on, for example, on the risk of CVD, cardiovascular disease, and how it's connected to nutrition. So students work with peer review papers. Of course, we help them through this process. They make predictions in groups. So these are some examples of the predictions of the graphs that they build. They co-annotate the papers using Adobe through the Google Drive options. And here, as I said, here students also explore their STEM identities. So there is a folder that students build progressively, starting from the very first unit till the end of the school year. So it's also on Google Drive, a career exploration activity. So this was genetics unit. So we created a template, and students can work. So we had 3 classes here. there were about 65 students in total. So they could contribute to the same document, usually maybe not more than 3 or 4 students working on the same document, or they could create their own document. So they could suggest a career, and they provide a summary of the career, university or college program leading to it, connections to other careers and disciplines, links to more resources about this career, demand for this career, and the salary, because students always are looking what will be the salary when I graduate, and how this career field is connected to the current unit of instruction. So we try to connect to each unit. Okay, and here they was researching about these different jobs and exploring these different jobs, for example, of forensic scientist, genetic engineer, genetic counselor, and many other jobs. And so we did some analysis of some preliminary analysis, and before and after the curriculum. And we look at what students are saying about the role of the community, about the role of the classroom community, of the role of scientific community. And overall, we found that by the end of the curriculum, students provided more high-level, more extensive responses on the role of the community, such as about the contributing to a total knowledge pool, improving the credibility and accuracy of the previous ideas, about the role of community in the classroom, such as sharing information to peers and learning from them, importance of learning through explanations and through discussions. There were more findings, and we're still working on the analysis of these findings. We identified main themes in student questionnaires that we collected after the delivery of this curriculum. For example, students said that looking at everyone else's work collectively gave me more insights about the details of various careers in biology and STEM. Students also found that there are many careers that they did not know about, that they existed. This is the main problem. Students graduate and they don't know what careers that they exist there. Students said they may now consider a career in biology, or they would like to narrow their interest to choices of careers, or these activities inform them about the qualifications and skills required to go into different careers, or show them different ways that biology can be applied to in the real world and industries. And maybe they also said, although they're not interested in science, it made me plan my future secondary education and job. There are some also questions that students still have about careers, such as about planning a career, what programs are best to take for each program, paths to a future career, what university, career and workload, resources, career integration. So for example, if they want to blend careers, blending business, marketing, and science, interdisciplinary opportunities, what is a job market looking like in future, changing careers, career in technology. It was interesting to see some students, they said, what if there will be robots replacing everyone in hospitals, right, in labs? So when we graduate, will there be jobs for us or not? And also there were some interesting quotes that students wanted, for example, to get a job in justice system for future. But now they may consider to have a job of a forensic DNA and analyst, because it combines science and justice system. So there were very interesting discoveries here. And so basically this is we're still in the process of the analysis of this. So this was just the outline of this project that we're doing. So we acknowledge the support by the grants from Social Sciences and Humanities Research Council and School of Graduate Studies of the University of Toronto. So thank you very much for your attention, and again for making this conference possible in these times. If there are any questions, I will be very glad to answer. And also I know that my paper is posted on the website. If you have any questions in future, this is my email here. You're always welcome to contact me. Thank you.
Thank you, Elena. This is really interesting. Are there questions while people are typing those? I love the idea that the students are exploring careers and what can I do with this degree, you know, when we finish. Even as teachers, we try to do that this education degree, you may not end up teaching, or maybe not teaching long, and what else can you do with that? So the fact that they are researching this is a very practical application of taking all the science courses, and I would think the students would be excited that they could see, you know, the different kinds of things they can do with their degree. So bravo! I think this is a great project. Do you do a follow up so that once they're past this program, you find out how many went into forensics, or how many went into horticulture, or, you know, different areas that they had learned about?
So I do not know yet, because we did it last year. Okay. So it's a good idea. Thank you actually for the suggestion. We will try. We will try to follow up with them.
Oh, good.
Who knows? Maybe
you have your topic for next year.
maybe in future I will meet some of the students somewhere in the science lab, and we'll see. I see the question there. Thank you. From Chiara. Have you noticed any difference between boys and girls in participating? Right. Thank you so much for the question. We have not looked specifically at this yet, but this is very good suggestion, of course, for as in other countries. In Canada is the same situation about engaging more girls to come to the science careers, especially in physics or chemistry. And thank you, Chiara. We will look at this as well. Thank you.
That's the great thing of a study, when you see potential to follow up on all your work and with new ideas. So that's wonderful. Other questions for Elena? Another minute or so. Elena, anything else you'd like to add?
No, so if there are any questions, yes, as I said, you're welcome to contact me. And this is research in progress, and I'm really happy about students' involvement and interest, as you said, because they see real applications. It's not the unit 1, unit 2, unit 3, and so on. This is something real that they will be doing in future if they would like, and that's why I think it's very useful.
And it gives them ideas. It gives them options. I think when we lock students into, this is your program and this is what you'll do when you get out, you know, that's exciting because that's what brought them to the university in the first place. But having other options, and I can, you know, I'm a teacher, but I can focus on language arts, or I can focus more on computer technology and education. So you're helping them to see those other possibilities. So I think that's great. We don't have any more questions, then thank you very much.
Thank you.
And we will get ready.